Okay, so welcome back. We are going to be talking today about our latest subject, which is a polynomial function. And we are going to start off by starting and practicing something that I think we could improved on from last semester, and that is taking notes in your journal. So I'm hoping that you all have your journals with you. If not, then I have this form that you can pick up from me that you can write on, and then just simply go back later and tape it into your journal. The one that you'll get from me, of course, doesn't have the pretty colors because I had to run it off on a black and white printer, but it's the same information. So what I've done is I've taken this definition right here, and I've taken all of the parts that I think we should talk about, and put them onto that piece of paper so that we can talk about them. So Springboard says here that a polynomial function in one variable is a function that can be written in this great big form where n is a non-negative integer and the coefficients a sub 0, a sub 1, and a sub n are all real numbers, and a sub n cannot be 0. That's the definition. What the heck? So what I did was like I said, I took it apart one piece at a time, a polynomial function in one variable. So we're going to stop right there and talk about what do they mean when they say in one variable. And it's not that big of a deal. It simply means that you're only going to have one variable. Now, um, the thing that I'm worried about is that some of you may get confused. If I took that f of x out and put a y, I'm going to give you an example of this is an example of a polynomial in one variable. The variable that we have right here is x, okay? It's not going to look like this. 3x squared y plus 3x plus 4y. This is an equation that has two variables in it, an x and a y. Okay, and it doesn't matter whether they're all written together in one term or whether you have an x term and a y term. You will do these at some point. Maybe not until you get to conics, where you're working with two variables, but over here, they're telling us that we're only going to have one variable. Even if they write it, instead of writing it f of x equals 3x squared plus 4x plus 5, this is still considered just one variable, even though we've set it equal to y. Because we're not doing anything to y, y is simply being calculated by plugging in values for x. So since y is not, nothing's being done to it, it's not considered a variable in the function. Okay, so all they're doing is right here is telling us that a polynomial function is only going to have one variable, and it most often is the x variable. Although it shouldn't matter to you at all what letter they use, but they're most often going to use an x variable. It is a function, so it's going to pass the vertical line test, and it can be written in this form. Notice it can be written. And these things right here, we'll come back and talk about these in just a second. What do they mean where they say that n, which is the variable, I'm sorry, not the variable, it's the exponent on the variable, and it's also the subscript of the coefficient. So it says n is non-negative. Why say non-negative? What is non-negative? Most of you thinking positive. Okay, and you're absolutely right. A non-negative integer is a positive number, but if we just say positive, we leave out 0. Okay, so they have to say non-negative because non-negative integers are positive integers and 0. So that means that the exponent up here can be a 0. As a matter of fact, we'll talk about that when we get right here. Okay, so that's telling us that this is a very important piece of what a polynomial is. This means that our exponents, I can't even spell exponents, E-N. Our exponents will only be positive integers. So what do we don't have to worry about it? What we do not have to worry about? We do not have to worry about exponents that are fractions. So we'll have no fractions as exponents. Now don't hear me say, you are not hearing me say that we won't have any fractions. Our coefficients can be fractions. It's our exponents that can't be fractions. Our exponents can't be fractions. Our exponents can't be negative. Our exponents can't be decimals. And let's see, our exponents can't be square roots because they're, and our exponents can't be a variable. Okay, it can only be a positive integer. So notice up here, our exponent is a 2, our exponent is a 1. This one right here, you're saying, oh, well, it doesn't have an exponent. It really does. Our exponent is a 0. And that's why we couldn't say just positive integers because we have to include 0. But what is anything raised to the 0 power? Anything raised to the 0 power is just a 1. So 5 times 1 is 5. So that's why we don't normally put x to the 0 power. But it helps to understand that constant, which we'll talk about in just a second, that constant does have a variable attached to it. It is the coefficient of a variable. It's just the coefficient of the x to the 0 variable. Okay, so what do we have? We have a polynomial function. It has, it's only going to have, it promises that it will only have one variable. It promises us that the exponents on those variables will be a positive integer or maybe a 0. But our exponents will not be fractions, negative, decimals, square roots, and it will not be a variable. The coefficients in front of each one of these terms up here, our coefficients, are going to be real numbers, and the leading coefficient, this a sub n, this leading coefficient will never be a 0, because if the leading coefficient is 0, then 0 times whatever this is makes that whole term 0, then it's no longer a term. So this is just saying that our coefficients will be real numbers. Now remember, real numbers can be square roots, they can be decimals, they can be negative, they can be fractions. So these are all the things that our coefficients can be, and they can, of course, just be regular numbers like 1, 2, 5. Ooh, they could be pi. Okay, so all of these are what our coefficients can be. So when I start giving the rules about the exponents, students only hear half of what I'm saying, and they think that nowhere can I have the square root of 2. No, the square root of 2 can be the coefficient, because my coefficients just have to be real numbers. It's my exponents that are restricted to only positive integers. Okay, and this right here was just saying that the leading coefficient can't be 0. We'll say in words, will not be 0. All right, so let's start looking at some of these terms that they give us. Okay, so in the Springboard book, they start talking about the highest power n is the degree of the polynomial. And then they tell us that the polynomial is in standard form, okay? And it's in standard form when all of the all the like terms are combined and they're written in descending order by exponent. So they give us an example right here. 7x to the 5th plus 2x squared minus 3. I'm running out of time, so I'm going to stop this video and start another one.